Hello, this is Richard Walker from Lucidate. Welcome to this first video in a series of 5. In this series, we'll take a close look at the Ethereum blockchain. The promise of Ethereum is huge. Ethereum seeks to make complex financial transactions both simple and affordable. Capital markets generate wealth for both consumers and suppliers. Large corporations are able to use capital markets to finance challenging projects and hedge complex risks. Financing and risk management make many projects and services successful that would otherwise fail. But provision of these financial services is expensive. The provision of all these services requires legal, compliance, risk, marketing, sales and trading personnel. All these services are legitimate. No one would suggest eliminating them, but they're very expensive. The consequence of all this is that these services can only be provided at scale. This results in very large commercial and investment banks that can only profitably offer these services to the very largest corporations. But if these services can be made simpler and offered more cost effectively, then the addressable market for financial services increases dramatically. A clear goal then of Ethereum is to make the provision of capital markets products simpler and more affordable. This means that similar but simpler products that are offered to large corporations by large financial markets firms can be offered to smaller enterprises. As well as making simpler financial products to reach untapped markets, Ethereum seeks to alter service provision. In centralized winner-takes-all markets, sectors get dominated by a small number of very large firms. This can stifle both innovation and competition. It becomes harder and harder to enter a market with an incumbent dominant supplier. Large centralized organizations also need many layers of management and coordination. These are internal costs to keep that organization dominant, not to improve the service to the customer. So Ethereum instead seeks to build a federated, decentralized financial services utility. By allowing different firms to provide their own components, entire applications can be assembled using loosely coupled services. No one single firm is in control. So the answer to the question, why Ethereum, is a clear one. Build simpler and more affordable financial services to address untapped markets. And how does Ethereum do this can be answered with it builds a global computer network with no central authority. It deploys loosely coupled components on this computer that can be assembled to provide efficient capital markets products. Let's dig a little deeper into what Ethereum is. We've said it's a global computer with no central authority. What does this actually mean? Well, the developers of Ethereum were well aware of what Satoshi Nakamoto had developed with Bitcoin. With Bitcoin, we have a global computer with no central authority. Bitcoin was a single-purpose system designed to transfer value from user to user. Bitcoin requires that users write tamper-proof transactions to a distributed ledger to transfer value from one user to another in return for goods and services. Miners validate these transactions and seal these transactions in a block by solving a cryptographic puzzle. For a more detailed explanation on how all this works, please see Lucidate's Introduction to Bitcoin course. There is a link below in the description. The tamper-proof transaction is written in Bitcoin script or Bitcoin code. This is a very low-level scripting language. Some common commands are shown on your screen. You absolutely do not need to know any of these commands or how these commands operate to use Bitcoin as a cryptocurrency. The most common type of transaction in Bitcoin is to reassign a UTXO by providing your private key. This looks something like the code on your screen. Pretty non-intuitive to the uninitiated non-developer. But, as I said, you don't need to know any of this stuff to use Bitcoin as a currency. Crucially, the Bitcoin design wanted these transactions to be a simple scripting language. The simple script should either execute correctly or it should fail. Satoshi Nakamoto understood that the Bitcoin network could be compromised if this Bitcoin script was more complex. The problem foreseen that was of most concern was a variation on a denial of service attack. At its simplest, this is just a never-ending loop. This never-ending loop could be written by a bad actor trying to attack the network, or by accident by an inexperienced developer. It doesn't matter which, the outcome would be the same. An infinite loop in a block being forever executed by every node on the network. No more Bitcoin. So Bitcoin script is an example of a programming language that is called Turing incomplete. When something is called incomplete, it sounds like an omission or something that is inferior. That is not true in this case. This choice was a deliberate design choice for Bitcoin to adopt a Turing incomplete script to guard against threats brought about by infinite loops. As Bitcoin is just designed to move currency about, this choice of Turing incompleteness turns out to be a very, very good one. However, the Ethereum designers had no such luxury. In seeking to deploy a general-purpose financial services utility, they had no choice but to adopt a Turing-complete programming language. This meant that they had to find a solution for the infinite loop denial of service problem. They also had another problem to tackle. Bitcoin is simply a payment system. It's easy to reward network operators for providing their payment validation services. But how do you reward the providers of more complex general services? Fortunately, there's a common solution to both these problems. That solution is gas. Think of gas as gasoline, the fuel for the Ethereum network. Every Ethereum operation consumes compute resources. This might be a simple operation like storing a small integer on the ledger, or it may be a complex one involving the interaction of many smart contracts. Simple operations consume a small amount of gas. Appendix G, perhaps named for gas, of the Ethereum technical specification lays out the differing gas costs for different operations. You can see on your screen, addition currently costs 3 units of Ethereum gas, and multiplication costs 5. As we're talking about gasoline, perhaps an automobile analogy is helpful. 1, the amount of computation matters. If you drive your car from San Francisco to Los Angeles, you will use less gas than a trip from San Francisco to New York. Secondly, efficiency of computation matters. If you take a trip in a Hummer, you'll use way more gas than if you drive a Prius. Finally, tax is an effective way to pay for common resources. Much as regular gasoline can be taxed to pay for road development and maintenance, Ethereum gas can compensate providers of compute resources on the Ethereum blockchain. The use of gas, interestingly, also solves the Turing-complete infinite loop problem. Not only does it incentivize good programming and penalize bad actors, but there's also a gas limit per block. Currently, the limit is 30 million gas. Please see the URL on your screen. This means that if a miner or validator includes a rogue transaction in a block, then this rogue transaction will attempt to run indefinitely. There's no way it can terminate on its own. Eventually, however, it will consume the gas limit in the block. Then it can be marked as a failed transaction, and any changes it made to the distributed ledger can be reverted. The final major difference between Bitcoin and Ethereum is the validation and consensus mechanism. You may recall that Bitcoin secures each block by requiring that miners compete to be the first to solve a cryptographic guessing game. This requires that they stake large amounts of fiat currency to build vast mining farms and power them with huge amounts of electricity. In contrast, proof of stake simply requires that validators stake Ether. The minimum stake is 32 ETH. A validator is chosen to validate the block at random, and if it turns out that they've acted fraudulently, then their staked ETH may be slashed. In essence, both staking and mining require large capital investments to participate, but only mining requires large amounts of energy. Ethereum is changing its consensus mechanism to proof of stake. This is currently scheduled for the second half of 2022. By the time you're watching this video, that change may already have occurred. So, in conclusion, why Ethereum? Well, it's to provide simpler, more cost-effective financial services to reach a larger market. How does Ethereum do this? Ethereum takes the core concepts of Bitcoin, a public distributed ledger and some clever ideas from cryptography to build proof and consensus. On top of this, it adds a Turing complete language. Not only does this allow for the transfer of cryptographic currencies between accounts, but it also allows for much more complex financial contracts and interactions, as we will see in future videos. What special problems has Ethereum had to address? Well, in order to pay for shared resources and to guard against abuse or bugs resulting in infinite loops, Ethereum has a policy of Ethereum gas. Gas is a micropayment that compensates providers of shared resources. Gas limits on blocks ensure that offending transactions and contracts can be unwound and removed from the pool. Finally, the proof of stake consensus mechanism allows for greater scalability, security, and energy efficiency than proof of work. The Turing complete language that Ethereum uses to power its smart contracts is called Solidity. Please join me in the next video where we take a closer look at Solidity and smart contracts.